In this video, we're going to look at the expectations for how to determine a rate law from data on a free response question. If you have multiple choice question, it is perfectly acceptable to say something like, hey, I'm going to compare experiment 1 and 2, and I notice the concentration doubles, and then compare what change the rate has to figure out the overall order of reaction. If you're trying to do this on a free response section, there's a little bit more you can do to show your work. So if we kind of think about the rate law like this, the rate is equal to K times the concentration of ClO2 to the X power, because we don't know the order yet, times the concentration of hydroxide to the Y power. We're going to set up a ratio. We're going to go ahead and use experiments 1 and 2. So we're going to do a ratio of the rate for experiment 2. I'm going to do experiment 2 on the top because it's got the higher concentration. I'd rather deal with numbers bigger than 1 than numbers less than 1. So I'm going to do experiment 2 compared to experiment 1. I'm basically going to set up two rate laws, like one in the numerator and one in the denominators. For experiment 2, the rate is 0.01104, and for experiment 1, the rate is 0.00276. And so we're doing the rate law as a ratio, so we'll have experiment 2, the rate would be K times the concentration of ClO2, which is 0.040, to the X power, times the concentration of hydroxide, which is 0.030, to the Y power. And on the bottom, it's 0.020 to the X power over 0.030 to the Y power. So obviously, K and K cancel out, 0.030 to the Y cancels out. So I'm just left with, on the right side, I have 2 to the X power. And on the left side, I have, when I divide 0.01104 by 0.00276, I get 4. And so we're trying to figure out 2 to what power gives 4. Well, that means X must be equal to 2. And this reaction is second order with respect to the concentration of ClO2. And we can do a similar calculation to figure out the rate order, or the exponent on the hydroxide in the rate law. So for that comparison, I think it would make sense to choose, I could either do experiment 1 and 3, or I could do experiment 4 and compared to experiment 5. I need something where the ClO2 concentration is the same, but the hydroxide concentration changes. So I'm going to choose to do experiment 3 compared to experiment 1. But again, multiple choices are okay. So the rate for experiment 3 is 0.00552. And the rate for experiment 1 is 0.00276. And on the other side, I set up the ratio of my rate laws. So now I can say 0.020 squared, 0.020 squared, that's the concentration of the ClO2, and I now know it's second order. And hydroxide, it's 0.060 to the Y power, and 0.030 to the Y power. So simplifying, the K's cancel, the ClO2 concentrations cancel, and so I'm going to get 2 to the Y power on the right side, and I really just end up with 2 on the X, or on the left side. So 2 is equal to 2 to the first power, so Y is equal to 1, meaning this is first order with respect to the concentration of the hydroxide ion. So now I can put this together and I can write the rate law. And I'm going to slide everything up a little bit because I'm out of room. So now I know from what I've calculated here that the rate law can be written as K times the ClO2 concentration to the second power, or second order, times the hydroxide concentration to the first order. And you don't have to write the exponent if it's 1. So I've written the rate law. Next, I need to figure out the value of K and the units of K. So I can pick any one experiment that I want to. It doesn't matter which one I pick. Might as well just do the first one. So I'm going to use experiment 1 to determine K. And I'm just going to plug in everything I know. So for experiment 1, the rate is 0.00276. K I don't know. The ClO2 concentration is 0.02 squared. The hydroxide concentration is 0.03, and that's to the first power. So I'm going to divide both those things to the other side, and I get K is equal to 230. The last step of this process is to figure out the units of K, and that's actually probably the hardest part. But when you have a question like this on the free response question, often figuring out the value of K is one point and the units of K are a second point, because the units of K are always different depending on what order of reaction that you have. So last step, determine units of K. And by the way, I want to emphasize this is always a lowercase k. Lowercase k rate law constant is not to be confused with a capital K that we will learn about the next chapter. They are not at all the same thing. So to determine K, I like to think about plugging in the units into the rate law. So the units for rate are going to be molarity over seconds, the change in concentration divided by time. K is what I don't know, so I'm going to kind of treat K like it's a variable. Concentrations are in molarity, so this will be molarity squared for the ClO2 times molarity the first power for the hydroxide. So then I need to divide both sides by molarity to the third power to get K by itself. And so I get K on the left side, and on the right side, when things cancel out, I will end up having this molarity cancel out one of these, and so the K units will be 1 over molarity squared times seconds. And so I'm going to come back up to the K here and add units, 1 over molarity squared times seconds. So it's a little bit of work here, but again, being able to figure out the units of K is very important. Just giving 230 as the value of the rate law constant is not going to get you all the points on that question. So that is an acceptable way to show your work when determining the rate law from data on a free response question.